Well, this week we are going to talk about system design. So, just a reminder of the context. Generally speaking, when we are creating a software system, we are trying to move from a vaguely described system, like the description of the system that is in a high-level human language that is vague and ambiguous. We go through various stages in order to try to add some specificity to that, to what needs to be done in the system before we reach the point that we can have that one specific implemented system. So we need to go through all these stages to reduce the ambiguity as we go. And in doing that, we go through some stages. So the general activities in the software development lifecycle involve some activities that would aim at figuring out what need to be done. Okay, so these are requirement elicitation and analysis. This is what we've been talking about so far in the course. And there are some activities that in which we plan on how are we going to implement the system. Okay, so there are two levels here of that planning or that design. There is a high-level system design, and then there is a low-level object design. Okay, and then there's the implementation, which is the actual like creation of the system and then testing, and then it keeps going until eventually the system is going to be retired. Okay, so now we're gonna start talking about the system design, okay, which is the closest step to the analysis, to the requirement engineering. Now, if you remember this diagram from the book that you've been using for the 2203, so we talked about the requirement elicitation and talked about analysis. Now we're gonna talk about this stage of system design. Now we see in the analysis we created some models that describe some of the objects or some of the entities or the classes that will be introduced or needed in the system. Maybe not in a lot of details, but at least to give us a general idea what are the entities that we have. Okay, now we need to look into a high-level organization of the plan on how are we going to organize these classes together before we start creating the system. Now see the detailed design where you add the details for the class diagram and in the other models as well. I'm only using the data model as an example. So here we created a data model on a high level. And then here we organize these data elements or data classes or entities into subsystems. And then later on, we're going to add the details to these the classes that were organized in the subsystem before the implementation. Okay, so we are focused on this stage here. What happens during the system design, we transform the analysis models into design models. Okay, so the general three activities that we are going to do is to identify design goals. Okay, so that gives us the prioritized list of qualities needed in the system. And we're going to talk about design goals in details, but this is should be the first step. Okay, and then there's the design of the initial subsystems. So we break down the entire system as we learned about it during the requirements engineering stage into subsystems. Okay, and there are some kind of styles or patterns that are known to be useful. We can always use them, but regardless whether we are going to use one of the known styles or the known patterns, system decomposition is very useful. Okay, and it's almost never the case that you're gonna find the best organization of your subsystems in the first attempt. You're gonna you need some initial attempt, so some initial system subsystem decomposition, some initial organization of the components of the system, and then there will be multiple rounds of review. So we refine this subsystem decomposition based on the design goal. So you take the initial decomposition and review the goals, the design goals. If something is not met, you refine your design in order to meet them, and so on in multiple rounds. Okay, so here's another view. If we are going to, if you want to see what's the input and what's the output of the stage, the system design stage, we have the non-functional requirements, the analysis objects. So all the models that we talked about during the analysis stage, plus the non-functional requirements are the input for this stage. The output is the design models and the system decomposition. Or I mean design goals and the system decomposition. We can also put it in a model, okay, but we'll see that one type of model that we can use for the organization of the subsystem. Okay. Now let's have an analogy of redesigning or designing a residential house so that we understand the process. Now, generally, an architect would have an agreement with a client. So this is reminiscent to the requirements engineering stage. Talk to your client, figure out what are the number of rooms, number of floors. Okay, so these are non-functional requirements. And then you're supposed to create a design in order for you to plan how this house is going to be created. But the non-functional requirements like number of floors, number of rooms, and all that are not sufficient. You need functional requirements as well. So how are these going to be used? Okay, so the function requirements indicates that the kitchen should be close to the dining room, the bathroom should be close to the bedrooms. And you can also use, so this is based on the discussion with your client. But this is not everything. Okay, you can also look at the standards in related type of systems or related or similar type of, if we're talking here about the residential houses, so similar houses in the area, similar houses in like the general style of this houses. Okay, so you can use the standards as a source of input to your design. Okay, so some of the standards would be like the kitchen cabinets come in fixed increments, beds come in standard sizes. Now, these kind of things may not have come in the discussion with the client, but it's important for you to know. So it's important that you do some research in the area. Okay, the kind of systems that you're creating, what are the standards there? Okay. Now the details, the contents of the rooms are not part of the architecture design. Okay, so the details are not part of the high-level design. Now we need to set what we learned in the of the requirements, either based on discussion with the client or based on the standards in this type of system, and put them in a list of constraints. Okay. But sometimes these constraints are not sufficient to define everything. Now, as you go through the design, you realize that there are some questions that were not answered. And it might be inevitable that you have to make some assumptions. And that's actually where the risk is. This always, though, if you have constraints that you have already discussed and agreed on, that's great. But you have to be aware that as you go, some details might be needed that were not part of the constraints, so you may need to make assumptions. And you need to be conscious about this because these assumptions need to be reviewed or verified. Okay, now for example, the walking, most of the walking will be done between the entrance and the kitchen. Between the kitchen and the living or dining area, and between the bedroom and the bathroom. So this is kind of the assumptions based on the general usage of any residential house. Okay, now another assumption might be that the people in the house would be spend most of the time in the living or dining area. Okay, so that's assumption based on the general usage of this kind of system. It might be safe and might be reasonable most of the time, but still need to be verified. For example, you may have a client that have a studio and wants to spend most of the time in the art studio, for example. So you need to be aware of the general assumptions that we tend to make based on the general usage of that system that need to be verified. Okay, now let's say we are done with the requirements and we're gonna start the design. So as I mentioned, it's almost impossible that it will be in one step. So the first attempt is never the best. So let's say this is the initial attempt. So we have the kitchen here, the stairs, study, dining, the entrance here, master bedroom, bathroom, and bedroom. Now, when we review the requirements, so this is the initial design, you compare that with the requirements or the design goals, we will see that the dining room is supposed to be close to the kitchen, right? So that's not good. So therefore, and then the second attempt, we refine our design and rearrange it so that the dining room would be close to the kitchen. Now, again, there was a requirements that, or there was a mention of there's groceries that needs to be offloaded from the door to the kitchen. So you don't want the entrance to be so far from the kitchen. So a second review led us to this third version of the design. Okay, so the third version is satisfactory so far. So we can start adding details. So once we reach to a satisfactory or a good enough architecture or high-level design, now we can start thinking about adding the details. Okay, so this is reminiscent to what we would do in a software system. We would divide the whole system into smaller components and interfaces between these components. So the interface in the house analogy would be like the doors or the entrances. The entrance or the exit between the different rooms. Okay, so in the software system, we need to divide the entire system into components, and we need to figure out how these components are going to be arranged. How are they going to be interacting with each other based on the functional and the non-functional requirements that we have gathered in the requirement engineering stage.